Okay, welcome back, physicists. This is number 14 on thermal physics, and we're going to get into the nuts and bolts of the ideal gas law. First of all, let's review the laws that we already know about. These are all empirical laws found by experimentation, Boyle's, Charles, and the constant pressure rule, and we can combine them into one form that looks like this: PV over T equals constant. Okay, so that's what we're really starting at. Now we can take that formula and we can go and find that constant. And we can include ideas about mass as well to get this overall ideal gas equation that PV is nRT. And this is what the variables are. Okay, pressure, volume. N is the number of moles of gas. Remember, a mole contains 6 times 10 to 23 particles. That's Avogadro's number. Big R is the molar gas constant. That tells you about the energy involved per mole for every Kelvin of absolute temperature. And obviously we've got T. Okay. That equation apply. Before we do that though, let's have a look. We can actually take that equation and we can plot a graph of PV over T, and that will tell us what this gas constant is. Because we know that PV equals nRT, that follows the form of y equals mx from your GCSE maths, where m is the gradient. And so if we plot PV against T, our gradient is the number of moles from the experiment on times by this constant, which is R. Now, all the other things we can measure pressure, we can measure temperature, we can measure volume, and we can measure the number of moles of a substance. We can weigh them to find the number of moles. So this is how we find the gas constant. So let's look at an example. Now, write this example down as we go. Pause the video if you wish, or you will need to. So we've got a cylinder and it's got 400 moles of gas. We know the temperature and we know the volume, and we're looking for the pressure in the gas. So here we go. Always, always, always. What do we always do? I can't hear you. We always write down the formula. PV equals nRT. We rearrange it because we're looking for pressure. It makes sense to rearrange at the beginning there to make P the subject. Put our values in and do the calculation. So there's our answer, 120 kilopascals. Fairly straightforward. Okay, let's get complicated then. So thus far, we've been talking about moles of gas, but being physicists, we like to think about just any number of particles. Okay, so now we deal with the Boltzmann constant, and this equation tells us the same thing, but this time we're looking at the number of particles, uppercase N, the number of particles in the gas. And so obviously we get a new constant, which is Boltzmann's constant. 1 and a bit, 10 to the minus 23 joules per Kelvin of temperature, of absolute temperature. We can get Boltzmann's constant, you can see on the screen there, via dividing it, the gas constant by Avogadro's number. And that's good to know, but there we go. All right, let's move on. So, putting both of these formulas side by side, look at this. They both follow the same form. The one on the left is dealing in numbers of moles. Remember, we can measure numbers of moles, and we can do that in the lab. The one on the right is talking about numbers of particles, where uppercase N could be any number of particles. And that obviously leads to a difference in the constants that we're looking at. So we have Boltzmann's constant instead of the molar gas constant. So the challenge with this, with these formula, is number one, looking at a question and selecting which formula is actually going to be correct. Okay. Number two, the other challenge is getting your head around moles and masses and numbers of particles and Avogadro's numbers. And the only way you're going to do that is just to dive straight in and actually do some questions. Now what I've got here next, I have some examples. Follow me through the examples, but write them down. Have a written record of examples that you can refer to, okay, when you are problem solving, because I will set you some problems at the end of this video. So number one, Pressure of an ideal gas we've given. We have a volume of 1.6 and we have 100 moles of gas. Okay, what is the temperature of the gas? Let's solve this problem. Let's write down the correct formula. We've selected that. Let's rearrange it to make T the centre of our interest. Let's sub in the numbers, and then we've got an answer of 462 Kelvin, and that number looks reasonably correct. It's in the right ballpark. If you get a number that's vastly huge or vastly tiny, you know you've made a mistake somewhere. Okay, let's move on to another example. Okay, this one's testing your understanding of molar mass and numbers of particles. What are we trying to do? We've got a mole, we've got just over a kilogram of nitrogen gas. We know its molar mass, and we're asked to find out how many molecules are present. Okay, so how we can solve this? Let's have a look. Okay, now we know that the number of moles is simply the mass of the gas divided by the molar mass. We looked at that previously. Substitute numbers in. So we know that in this sample we have 35.9 moles of gas. Now, to find the number of individual molecules, remember each mole has Avogadro's number of particles. We just multiply a number of moles, and there we go. And we get a really big number. That's 2 times 10 to the 25, that's 25 zeros. So that makes sense because atoms are small, and we've got a kilogram of nitrogen gas. That's going to be a lot of individual atoms. Next example. What are we trying to find here? We're asked to find pressure. We're given temperature in degrees C, which is a no-no. We have to convert that. We have an ideal gas. We've got volume, and we're given the number of molecules. So the first thing we need to do is select the right formula. And in this case, we're using the form NKT. Rearrange to get our subject, substituting the numbers, being careful that we turn 45 degrees C into Kelvin, and then we've got our solution there. We have our answer. Okay. Next, we want to know how many moles of gas are in this cylinder with a certain volume, at a certain temperature, and a certain pressure. Some issues here because we've got volume in centimeters cubed, which is no good to us, and we've got temperature in degrees C, which is no good to us. So, solution, the first thing we always do. Write down the formula. And this is the correct form for this solution. We're looking for N. Let's do some value conversion now. Okay. Note, 500 centimeters cubed, it's 5 times 10 to the minus 4 meters cubed. Okay. And obviously temperature is transferred there. And then we substitute in the values, and then we get an answer out. We have 0.172 moles. Okay. So, moving on. These are the questions that I've set you. You may have a paper copy. There will be a copy on the PowerPoint. If not, there's a copy here. Freeze the screen and do it. These are 4 problems which will summarize and help you to understand the gas laws. So do them. In the next few videos, I will show you the solutions, but do them before you look at the solutions. Okay, kids, you must have a go before you see the solution. So enjoy.